Okay, this is going to be a 2-day note sheet. And this stuff, you guys kind of already went through the book and found, so we're going to go kind of quickly through it. But the graph of, or this is the definition of a quadratic function. And the graph of a quadratic function is a parabola. A parabola is U-shaped, symmetric with the axis of symmetry. The vertex is going to be the lowest point or the highest point on the graph. And then today we're going to focus on writing the quadratic functions in what's called standard form, where you can just look at them and tell the vertex. So this is standard form. I think in Algebra 2 they call it vertex form, but HK is the vertex. X equals H is the axis of symmetry. The parabola will open upward if A is positive and downward if A is negative. Okay, so to write a quadratic function in standard form, you must complete the square. All right, so we'll talk about these steps as we do them. It's slightly different than solving by completing the square because we're only working on one side of the equation, so we don't add the same thing to both sides. Slightly different, but we can do it, don't worry. All right, so just real quick, this last step where you write the trinomial as a binomial squared, I think you guys remember this, but we would do x, and then this sign comes down, and then it's what you got when you took half. And then same thing here, bring this sign down, what you get when you take half of 14. Okay, so let's look at example 1, and I'll go back to the steps as we do them. All right, so our first step is a super duper easy step. Your first step is to put the x terms in parentheses. Everybody can do that. All right, the next steps, sometimes we have to do and sometimes we don't. You're going to factor out the coefficient of x squared only from the x terms. Now this one doesn't have a coefficient on x squared, so we don't have to do that step. All right, the next step is to take half of the coefficient of x and square it. Add this value inside the parentheses. So we're looking at 10. We're going to take half of 10 and square it. That's going to be 25. We add that inside the parentheses. Okay, and then the second step, or the second part of that step is multiply it by the number you factored out and subtract this outside the parentheses. So in this case, we didn't factor out a number, so we're just going to subtract it. All right, so that's where it's different than when we solved by completing the square. We added the same thing to both sides. So on this side, this way, we're adding it and then we're subtracting it right away. So it's like nothing happened. You change the way it looks. You don't change the value of it. All right, and then our last step is to rewrite that perfect square trinomial that we did as a binomial squared. So this one would be x plus 5 squared. And then outside we would do 13 minus 25 is negative 12. All right, now don't just zone out and think you're done because they definitely get more challenging than this one, so hang in there. Our vertex, we do the opposite of what's inside the parentheses, so negative 5 for the x, and then we leave the 12 like it is, so negative 12. Minus 12 means negative 12 for the vertex. The axis of symmetry is always x equals the x part of the vertex. The direction of opening has to do with what's in front of the parentheses, so that's a positive one there, so this one would open upward. All right, now we're going to find the x-intercepts algebraically. So what we're going to do is use the standard form, and the x-intercepts are going to be when y equals 0. So we'll take that standard form and we're going to set it equal to 0. All right, and this should just be a couple of steps. So we would add the 12, well, maybe more than 2, 3 steps, and then take the square root. Don't forget that when you're solving an equation by taking the square root, you take the positive and negative square roots. And the square root of 12 can be broken down because 4 goes into it, so it can be broken down to 2 square root of 3. All right, and then we'll move that 5 over. All right, now we're going to do a little sketch in a second. So I actually leave the answer like that for an exact answer, but I need to know what that equals. So we would take our little calculators that aren't too smart, and we would type in -5 plus 2 times the square root of 3, or it might be easier if you just do -5 plus the square root of 12. All right, and that's going to give you -1.536. Right, and then we would do -5 minus the square root of 12, and that's going to give you -8.464. So those are your x-intercepts. If you ever were asked to give them as ordered pairs, that would be the x, and the y would be 0. So sometimes you're asked to give them that way. All right, so when we do this sketch, this is just an extremely basic sketch. Everything is negative here on the x's. So our vertex is on the negative side of the x's, our x-intercepts are on the negative side, and then our vertex is all the way down at 12. So it's going to be mainly the third quadrant. So I'm going to go by 2's. All right, so I have -512 for my vertex. And then I have an x-intercept that is almost -8.5, so we'll put that there. When that's almost -1.5, so we'll put that there. And then we'll just draw this, open it upward. We'll just draw a U-shaped graph. It's not beautiful, but that's okay. Okay, so that's a lot of steps, but none of them are crazy hard, but we can do them. All right, this next one is going to be slightly more challenging, I can already tell, because there is a coefficient on your x squared. So let's do the first step, which is super easy. We put our x terms in parentheses. All right, this time we do have to do the second step, where we're factoring the coefficient of x squared out of only the x's. All right, our next step is our step where we complete the square. Okay, so it says to take half of the coefficient of x and square it, add this inside the parentheses. So that's going to be 16. All right, pay attention to the second part of that sentence. Multiply it by the number you factored out and subtract outside the parentheses. So because of the distributive property, I didn't just add 16 add 16. I technically added 2 times 16. So to keep it balanced completely, that's what I have to subtract. All right, and then we'll write this. So that's going to be 32 minus 32, which is 0. So that's it. Okay. So our vertex is the point 4, 0. because the 2 in front of the parentheses is positive, this one would, oops, I didn't read the direction, sorry. The axis of symmetry is x equals the x part of the vertex. This one opens upward. All right, to find our x-intercepts, we actually already know it, but technically we could take this and set it equal to 0, divide by 2, take the square root of 0 is 0, add 4, but we kind of already knew that that is the x-intercepts because the y value is 0. Okay, so then when we do a sketch, this one we have less information, but that's okay. We just know the vertex is at 4, 0, and that's also the only x-intercept, and it opens upwards, so we're just going to do that, and that's going to be good enough. Okay, so let's look at the next one. Start off by putting the x terms in parentheses, factor out the coefficient, complete the square inside the parentheses. Outside the parentheses, you're going to subtract what you factored out by what you added in. All right, so we're basically subtracting -3. 9 minus -3 is 9 plus 3, which is 12. Okay, so that's going to make our vertex 112. That's going to make our axis of symmetry, x equals 1. This one, because there's a -3 in the front, is going to open downward. All right, our x-intercepts will set our function equal to 0 and solve by subtracting 12, dividing by 3, taking the square root, and then adding 1. So when we add 1 to 2, we're going to get the point 30. And when we add 1 to -2, we're going to get -10. That's going to help us do our sketch because it's going to just be a little easier to do. Okay, so I don't have a lot of room, but we'll make it work. So this time we have both sides on the x's. We have some positives and we have some negatives, but our y is very positive. All right, so to save on space on my y's, I'm going to go by 4s. So 4, 8, 12. All right, so we're at 112, and then we have 2 x-intercepts. Boom. Let me try that again. Boom. You actually can get the y-intercept from this number when it's in the original form. 9 is where it should cross the y-axis. Okay. Why don't you guys try number 4 on your own and then pick back up and see if we ended up doing the same thing. So in that one, we did have to do minus negative times the 36, the negative that we factored out. So be careful. This is one that a lot of people tend to make a careless mistake on. So we'll divide by the negative, take the square root, and move the 6 over. All right, I'm going to skip out on the sketch on this one just to save some time. All right, so check your work, see if there's something you may have made a mistake on. Okay, now this is the one I've been waiting for. This is where it gets kind of messy when things just don't turn out so pretty. So we're going to start off the same way, where we'll do our parentheses, and then we'll factor out the coefficient of x squared. Now what happens this time is when we do, it gives us this ugly odd number. Okay, but we can still do this. We can take half of 3 and square it. So to square that, you square the top and you square the bottom. All right, and then outside, we're going to subtract what we factored out, which was 2, times what we added, which is 9/4. All right, and then here is what we got when we took half. What we get when we take half is 3 halves. All right, so when I multiply 2 times 9/4, I'm going to get 9 halves. And then to subtract those, I need a common denominator. So I'm going to rewrite -1 as -2 halves. So -2 halves minus 9 halves is -11 halves. All right, so that puts our vertex at -3 halves, -11 halves. Axis of symmetry is -3 halves. X equals, we need the x equals, sorry. Direction of opening is upward. All right, and then we'll do these x-intercepts real quick. Oops. All right, so let's move over that 11 halves. And then let's divide by 2. When you divide a half by 2, you get a 1/4. All right, and that helps us out when we do the square root. So we're going to do the square root of the numerator, which is the square root of 11, and then we'll do the square root of the denominator, which is just 2. And then we'll just move that 3 halves over. There it is. All right, so your assignment, this is kind of weird, but what I want you guys to do on page 120 is 1 through 6, and then 8 through 14 even. Actually, just kidding. You already did that. I just want you to do 20 through 40 by 4s. So start with 20 and do every 4th problem. So every problem you do should be a multiple of 4.